Welcome back to another video. So in this video I'd like to talk about a topic called built-in functions. So it's good to know that in Python there are some built-in functions which are regularly used for different use cases, and I'll look into some of them. I won't go through all of them. There's lots of documentation about this, but just to give you some type of overview of what is available in Python as a language. So let's just look at writing. Let's just look at one of the built-in functions called the input. So the input function, if we use that, we see that it reads a string from the standard input, and the trailing new line is stripped. And it also takes a prompt argument, so you can say, please type your name, for example. We can save this to a variable, say name. And then we can use another built-in function called print, which we have seen at this point. And I'll just print that out. So I'm taking input from the user, and then I'm printing out what we have taken as an input. So let's run this to see. These are two built-in functions into Python. Let's run this and see. Please type your name, Bob, and then we see that it prints out Bob. So this works fine. If we look into, I can give another example of a built-in function. So for example, I can print out the length of the input that I took as an input. So this is also a built-in function. So it returns the number of items in a container, and it could be also if I'm not mistaken, I think it should work with strings as well. Let's see. So let me clear the console and let's see again. Bob, and then we see 3. So that's because the Bob is a string with 3 characters, right? If we continue to look into other types of functions, so this was what I would say just regular functions, regular built-in functions of different types. No particular, I wouldn't say that they have much in common. So common use cases, you would say. But then we have other functions that are built in that work mainly with data types. So this is a bit different, and this is often used when we want to build some type of data structure, but it could be used for many things, right? So let's just use some of the basic things. So one of them is the str method. And what this does is that it creates a new string object from the given object. And you would say, okay, but why is that interesting? So one thing would be that, for example, let's say we want to compute an arithmetic, we want to make an arithmetic operation. So we want to add 2 numbers, right? So I'll say total is equal to 2 plus 2, right? And if I want to print this out, what do you think will happen? Is it possible to print out? This should be possible, right? Let's see. Yeah, so that is possible. However, let's see if I try to, for example, say the total of 2 plus 2 is, and then I concatenate total, right? What do you think will happen now? So I'm concatenating, this is called concatenation. So I'm concatenating a string with an integer, right? So what would you think will happen? So let's run this and see. And what we see is that it crashes, right? And the reason why it crashes is because you can't concatenate a string with an integer. So this is what brings me to the data type function. So there is a built-in function in Python called str, which will convert an object to a string object, right? So it will convert this integer and return a string, and therefore we can then concatenate it. So let's see if I run this now. Now we see the total of 2 plus 2 is 4. So this works fine. Let's move on to another example. So yeah, I would say let's try the opposite. Let's see if this works. Or let's look at, so let's say I have a number, num, I call it num, and it's actually set to a string, and I want to convert this to an integer. So I'll say num int num, right? This may be really confusing now, but let me just print this out. Instead of saving it to a variable, I'll just print it out like this. Print, and let's see what happens now. So it says 2, that's nice. And now I want to actually say +2, right? And I want to see 4 now, because I know that this is converted to an integer, and this should now be there. It should actually do the arithmetics, right? So let's see. Yeah, and that works fine. However, if I try to add +2 here, this would not work, right? Because this would not be an arithmetic operation, since this is a string and this is an integer. So this would render in a type error, right? Yeah, it would result in a type error. So that's good to know, that you have the int method to actually convert a string to an integer, and then do arithmetics here, for example, adding 2 numbers. So let's look at the final group of built-in functions that I want to show now. So these are iterator functions, and they can be quite interesting because many times you deal quite often in programming, you deal with lists or arrays or different types of data collections, and you want to perform some type of search, or you want to do something with this list. You might want to search for an item. You might want to check if all the items fulfill a certain criteria, and so on. So there are many use cases for using or iterating, and then there are some helper functions that you can use to perform these types of common iterations without having to write lots of code. You could technically write a for loop and do everything in a quite imperative way, but you could also use these types of functions, which would kind of remind you of more functional programming. So you don't really care much about how you, for example, filter out things from a list. You just want to do it, right? So let's look at one example which is quite common, and this has to do with if you have let's say you have a list. Okay, I'll create a list. I'll say students. The first student is called Bob, the other one is called John and Sarah. Okay, and I want to print out the name with the actual index, right? So how would you do this in a for loop? So you could say student in how to say range len students, I guess that's how it is, right? Print student. Let's see if this works. I hope this works. Yeah, so this prints out the only 0, 1, 2, right? So it's not the actual student, but it's kind of the index. So if I want to print out the actual name, I have to access it with its index, right? So like that. But another way, let's say I want to get both the index and the item itself, then you could use something else called enumerate. So let's look into that. So let's say for I'll say index and then student in enumerate students, and let me print this out now. So let me print out index, right? and let me print out student. And this would not work, right? Because this is an integer and this is a string, and this concatenation would fail. So I'll have to do it like this. I'll use the string method, as I said before, and then I can say plus, just for some formatting. You can format this in different ways. You could also use the format function as well, but I'll just do it like this. Let's see if this works. So we see that we get both the index and the name. So it's good to know that you have this enumerate helper function that you can use for this quite common use case. Another really common use case is that you might want to filter out values from a list, right? So let's say I have a list of numbers. Okay, so I'll just call them numbers for the lack of better name. So I'll just say 2, 5, 8, 11, 15. Okay, and I want to filter out. All the values that are less than 10. Okay. So how would I do this? So first and foremost, this requires that you define a function, and we will get into functions quite soon. But I just perhaps it would be better to. So how do I filter this out? So I will define a function, which I will say filter by greater than. Okay, I'll just say greater than 10. Greater than 10, I guess would be a nice name, I guess. I hope this work. Will this work actually? Of course, there has to be a parentheses, right? Of course, and you also need to take the parameter, right? So I'll say n because it's a number, right? And I'll say return n if it's, so it should stay if it's greater than 10, right? So if it's 10 or less, then let me also include 10 just for the sake of clarity. And let's see what happens now. So I will print out everything now. Okay, so I'll say for item in filter greater than 10, and I want to filter out what's in the numbers, and I'll say print filtered out, and I will say item like this. Let's see if this works. Quite interesting. Yeah, so we see that this list now, or what this returns, it returns a new list which only contains the objects that fulfill this criteria, right? So what it means is that if the given number, which will be 2 in this case, if it's greater than 10, then it should stay. It should be part of this new list that will be returned. Else it should not be part of it. So this is less than 10, so it does not fulfill it. This is less than 10, this is less than 10, this is 10, so this will not fulfill this criterion because the criterion is that it should be greater than 10, right? So that's why we see only 11 and 15. And similarly, you could do the same thing using another syntax, a more simpler syntax, and I will get into that later as well a bit more, but for now it's just good to know that we have what's called lambda expression. So it's kind of a simpler way to define this than having to define a function like this. So you would say for item in filter, and I'll say everything that is less than 10 should stay. Okay, so this is a bit different. So I'll say lambda n less than 10, right? Less than or equals to 10. Let's try that. And let's say numbers, right? Because we want to filter it on numbers. And let's print out less than 10 item. Let's run this. I can barely see what happens. It's actually less than or equal to, right? Because I included the equal sign, so it could be equal to as well. So let's see, let's run this now again, just for clarity. So we see that this new list will be 2, 5, 8, and 10. So this is a simpler or a more elegant way to write this, right? It is quite similar, but it's a different syntax. It's good to know that it exists. And finally, I'll just show another thing, which is about maps, or not maps, not the data structure maps, but in Python you have a built-in iterator function called map. And what it does is that I usually like to think of it as it transforms something. And we have a similar function in JavaScript if you're familiar with that language. So you can say that, for example, if I have a list of people, so let's say people, Tom, Tony, Tina, okay? And I want to say, let's print out the length of each character. Okay, maybe I can say Anthony, okay, just for the sake of the length of the string, right? So it should print out 3, then 4, and then, yeah, what is it? 7. So I'll say for item. Item is maybe not a really nice name. You could just say something else like person in. And now I will define a map. So this is what I would say it transforms each item into something. So it could be, for example, you have salaries or something, and you want to like increase each salary by 0.15. Like you want to multiply it by 15%. Okay. So let's, but for this simple case, let's just print out the length of each string. So I'll just say p. The syntax is like this: p, and then return the length using the len built-in function. So p, and I also have to provide the actual. I'll just say print length. I think I will actually rename this to length person, right? I think it's a better name. And this is not sufficient, right? Because it has 2 parameters. So the first one is the lambda function, and the second one is the actual list I want to loop through, people, and I can maybe say it's persons. It reads easier, I think. So length person in persons. Let's run this and see what happens. So 3, 4, and 7. 3, 4, and 7. So it's a nice way to map something. Another thing would be to say, as I mentioned before, so let's say you have salaries. You have 1,000, 2,000, and 1,500, and you want to say increased salary in map, and now you want to say for each salary, I want to say S times 0.15, right? So I want to increase, everyone gets a 15% bonus, right? Right, so let's print this out. It's a generous company. So let's see what happens now. If I print this out, oops, yeah, that's good to know. It fails, right? What's the problem? The problem is that I didn't provide the list, of course. It's a silly mistake, like this. And let's run this again. And now we see, oh, I actually decreased it. That was stupid of me. 1.15. My math wasn't proper. That was good. Good that it. So now we see that it actually increased the salary with 15%, which is nice. And here we can also see the floating problem. It's a quite common thing that sometimes. So in programming, you usually have problems with floats, right? Thanks for watching. This was a